Today, I am going to explain the formation of PN junction, that is unbiased PN junction, forward biased PN junction, and reverse biased PN junction. The PN junction is formed by joining two types of semiconductor, P-type semiconductor with holes as majority carriers, and N-type semiconductor, electrons as majority carriers. The P-type region has many holes. They are positive charge carriers because the p-type semiconductors are doped with trivalent atoms like boron, whereas the n-type region has many electrons. The electrons are negatively charged carriers because it is doped with pentavalent impurities like phosphorus. Okay, so when p and n-type materials are pulled together, the free electrons from N-type semiconductor region starts moving into the P-type region. Similarly, the holes from the P-type region, they start moving into the N-type region. As the electrons and holes combine at the junction, they cancel each other, leaving behind a region with a free charge carriers. So this on the P side, uh, free charge region with no free charge carriers. On P side, it is negatively charged, negative immobile ions, and on N side, positive ions. So this area is called depletion region, and it acts like a insulator. In the depletion region, the yellow color one, in this region, fixed positive ions, they are called as positive. In N-type material, positive ions are formed, and in P-type material, negative ions are formed. So in this depletion region, fixed positive ions, they are immobile. The fixed positive ions and negative ions are left behind, and which creates a small electric field. So the flow of electrons and holes, they stops because of this electric field in the depletion region, and this electric field prevents further movement of electrons and holes. The PN junction is now stable. Now it can control the flow of electricity. So this is all about the formation of PN junction and the unbiased PN junction. Now, I'll explain under forward biased condition what happens. This is forward biased PN junction. Okay, then the positive terminal of the battery, it is connected to the p-type region, and the negative terminal of the battery, it is connected to n-type region. Then the diode is said to be in a forward biased mode. So the applied voltage, this applied voltage reduces the potential barrier which is created by the depletion region, because the holes are attracted by the negative terminal of the battery and the electrons are attracted by the positive terminal of the battery. Due to this, the depletion region becomes narrower. As the external voltage, it will aid the movement of charge carriers. So the electrons in N-type region, they gain energy and they move towards the P-type region. Similarly, the holes in the P region, they gain energy and they move towards the N region. So due to this, the current flow as a charge carriers, the current flows as the charge carriers cross the junction. Holes will cross the junction and they go towards the negative terminal of the battery. And the electrons in the N region, they get energy and they move towards the P region. Due to this, the electricity current flow. So the PN junction conducts, due to this, the PN junction conducts the electricity and it will allow the current to flow through the circuit. So this current increases exponentially as you increase the battery voltage. So this is all about the forward bias. So under forward bias, the current flows exponentially. It is initially current is zero. So after certain amount of current, that is forward voltage, that is knee voltage, 0.7 for silicon and 0.3 for germanium, the current starts increases. This is called as a forward region. Then this is the reverse bias characteristics. So the positive in the reverse bias, the positive terminal of the battery is connected to the N-type region. Sorry, the positive terminal of the battery is connected to the N-type region, and the negative terminal of the battery is connected to the P-type region. The applied voltage, this applied voltage increases the potential barrier because the holes in the P region are attracted towards the negative terminal of the battery, and electrons in the N region are attracted by the positive terminal of the battery. Due to this, the potential barrier increases. The depletion region widens as the more positive and negative ions are left behind. The depletion region becomes more. So the electrons and holes are pulled away from the junction. Holes are pulled away from the junction. They start moving towards the negative terminal of the battery, and the electrons are pulled away from the junction, and which will prevent their movement across the junction. So no electrons and holes are crossing the junction. But a very small leakage current flows due to the minority carriers, because electrons are the minority carrier in p-type region and holes are the minority carrier in n-type region. The electrons from p, the minority carrier, will cross the junction and come towards the positive terminal of the battery. Due to the minority carriers, a very small current in terms of microamps current flows in the reverse biased PN junction. In this way, the PN junction blocks the current flow and it acts as an insulator. However, a very small leakage current may still flow because of the minority carriers. If the reverse voltage increases further and if it exceeds some critical value, then the PN junction undergoes a breakdown. So this breakdown is called as Zener breakdown or a avalanche breakdown. So because of this junction breakdown, a heavy current flows in the reverse biased condition. So this is all about PN junction under reverse bias.